In the last class, second lesson about the mystery of matter has completed. Today we will discuss class number 3, mystery of matter under composition of matter. Composition of What is the composition of matter? The arrangement of molecules. The arrangement of molecules determines the arrangement of molecules determines the physical state of a substance. Physical state of a substance. Physical state of a substance. The arrangement of molecules determines the physical state of a substance. However, the composition of a substance determines the composition of a substance determines the nature of the substance. So, arrangement of molecules determines the physical state of a substance. Composition of a substance determines the nature of the substance. What does it mean? For example, water. This is salt water, sea water. And the second one is distilled water. Okay, sea water has a salty taste. While distilled water, no taste. Why? Seawater contains dissolved salts, but distilled water contains only water molecules. Seawater contains dissolved salts. Dissolved salts. Okay, distilled water has only water molecules. So, the taste of seawater is different from distilled water. Okay. So, the composition of substance determines the nature of the substance. Seawater has NaCl. Its taste different from distilled water. Seawater contains dissolved salts. Distilled water has no dissolved salts. It is the purest form of water. Only H2O molecules. So, nature different. Nature of the substance different. So, nature of the substance depends upon the composition of the matter. If the composition is changed, nature of the substance is also changed. If the composition of the substance is changed, nature will be the change. Nature will be the change. Okay. Next. Pure substance. Pure substance. Pure substance. The substances which contain only one kind of molecules. The substances which contain only one type of molecules. Only one type of molecules. Only one type of molecules. Example, chlorine. Purest chlorine has chlorine molecules, Cl2 molecules, nitrogen molecules. Nitrogen gas has nitrogen molecules. Nitrogen gas has nitrogen molecules only. Oxygen has oxygen molecules only. Sodium has only sodium atoms. Okay, sodium does not contain any other matter. Only it contains sodium atoms. Magnesium contains magnesium atoms. Okay, calcium contains only calcium atoms. So calcium is the purest substance. Okay, next, helium, neon, argon, krypton, sulfuric acid, H2SO4. If you take sulfuric acid, purest sulfuric acid, containing only H2SO4 molecules. Similarly, purest water, all the purest water has only water molecules. So, the substance which contains only one kind of molecules are called pure substances. Next, mixes. Substances which contain more than one kind of molecules. Mixes. Substances which contain more than one kind of molecules. More than one kind of molecules. More than one kind of molecules are called mixes. Okay. Examples: H2O plus NaCl. H2O contains NaCl. NaCl dissolved in water. So it is a mixture. Air is a mixture. Air contains carbon dioxide plus oxygen plus nitrogen. So air is a mixture. Okay. And another one is diluted HCl. It contains water plus HCl. And diluted sulfuric acid. It contains water plus H2SO4. Okay, and alloys. Alloys containing a mixture of metal, copper plus zinc. This is called brass. Copper plus zinc is called brass. This is alloy. So it contains mixtures, substances which contain more than one kind of molecules are called mixtures. The best example is air. Air is a mixture. Air consists of so many different molecules: oxygen, nitrogen, carbon monoxide, carbon dioxide, inert gases, ammonia, okay, HCl vapors, hydrogen sulfide gas. So these are called mixtures. And distilled water is a compound. Distilled water is a compound. Seawater is a mixture. Distilled water is a compound. Seawater is a mixture. Distilled water is a pure substance. In other hand, distilled water is a pure substance, but seawater is a mixture. Okay. Next, pure substances are classified into two categories. Pure substances are classified into two categories. One is elements. And second one is compounds. Pure substances are classified into two categories. One is elements and second one is compounds. This is based on ability to separate. This is based on ability to then separate. Okay. For example, H2O. H2O is said to be compound, not element. Why? When H2O is heated, it decomposes into hydrogen and oxygen. Okay, so H2O is compound. When hydrogen is heated, it is not decomposed. It is not decomposed and it does not produce two different substances. And it does not produce two different substances. So H2 is element while H2O is compound. Similarly, oxygen is element. When oxygen is heated, no two different elements are formed. Different elements are not formed. When oxygen is heated, two different elements are formed. So oxygen is considered as element. Hydrogen is considered as element. H2O is considered as compound. Why? When H2O is heated, two different elements are formed, hydrogen and oxygen. When hydrogen is heated, only two different elements are not formed. So hydrogen is the element, oxygen is the element, H2O is a compound. And another example, many more examples. Hydrogen peroxide. Hydrogen peroxide is compound. It is not element. Why? When hydrogen peroxide is heated, produce H2O plus oxygen. So H2O2 is compound. Again, H2O is compound. Oxygen is element. Why? When H2O2 is heated, two different two different substances are formed. Again, when H2O is heated, hydrogen and oxygen produced. So H2O is compound, oxygen is element. And another example is 2KClO3. 2KClO3 gives rise to 2KCl plus oxygen, 3O2. So KClO3 is compound, KCl is compound, but oxygen is element. And another example is when ammonia is heated, produce N2 plus 3H2. So ammonia is compound. Nitrogen is element. Hydrogen is element. When nitrogen and hydrogen are heated, no two different elements are formed. That's why nitrogen is considered as element. Hydrogen is considered as element. But ammonia is compound. So conclusion: sulfur dioxide, H2O, sulfur trioxide, okay, sulfuric acid, HNO3, HCl, ammonia, NH3, KClO3 are compounds. Because on heating or any chemical reaction, they produce two different substances. That's why these are called compounds. Generally, a compound is made up with different kinds of atoms. These are the compounds. Any compound can be made up with different kinds of atoms. Generally, these are elements: nitrogen, oxygen, sulfur, phosphorus, okay, fluorine, bromine, okay, sodium, potassium, rubidium. These are the elements. On heating, they do not produce two different elements, two different substances. These are the compounds. This is the main difference between compounds and the elements. Okay. Next, mixes. Generally, mixes containing more than one type of molecules present into it. Mixes are substances which has which has more than one type of molecules. More than one type of molecules present into it. These are called mixes. Okay. So, what are the characteristic properties of mixes? It has any composition. It has any composition. It means water contains lot of salt. For example, seawater contains lot of salt, but pure water, lake water contains a small amount of NaCl, but seawater contains a large amount of NaCl, but lake waters, river waters also contain NaCl, but they containing a minute quantity of NaCl. Okay, So any mixtures contain any composition. Best example, alloy, brass. Brass is a mixture. It contains copper and zinc. It contains copper and zinc. Copper 60%, copper 60, brass has copper and zinc. Copper is 60% and zinc is 40%. So this is the mixture. Next, no specific set of properties. Second one is no specific set of properties. No specific set of properties. And the third one is properties of individual constituents retired. Properties of individual constituents retired. For example, NaCl present in water. When NaCl present in water, the properties of water does not change, and the property of NaCl does not change. When you prepare alloy, brass, copper and zinc, when copper and zinc is mixed, the properties of the copper do not change. The properties of zinc do not change. Okay, so properties of individual constituents are retained. Properties of individual constituents retained. Next, mixtures may be homogeneous and heterogeneous. Mixtures may be homogeneous and heterogeneous. So air is mixture. It is homogeneous. Air is mixture. It is homogeneous. Why? Air contains different substances. CO2, CO, carbon dioxide, okay, nitrogen, oxygen. But you can see air in a single phase. Our naked eye can't see different substances in the air. So air is homogeneous mixture. When NaCl is dissolved in water, you can find only water, but not NaCl. NaCl is completely dissolved. Actually, when NaCl is present in water, there are two substances, NaCl and water. But you can see only water, not NaCl. So it is homogeneous mixture. Okay, next. When sand is present in water, sand plus water, this is a heterogeneous mixture. Why it is a heterogeneous mixture? You can see both sand and water. So this is a heterogeneous mixture. So mixtures are classified into two types. One is homogeneous mixture and second one is a heterogeneous mixture. A homogeneous mixture contains only one phase, but a heterogeneous mixture contains more than one phase. Example, sand in water, you can see both sand and water.